Hello, welcome to our semiconductor education program. I'm Vincent Chang. In this lecture, I'm going to present an IC power amplifier, part 1, intro. If you Google LM380 power amplifier, you will find a lot of information from the website, including this one. It's an IC audio power amplifier which is originally designed by National Semiconductor. Here is its data sheet. It says the amplifier is the LM380 is a power audio amplifier for consumer application. One of its important features is its creation output voltage is at 1/2 of the supply voltage. I will explain this in the next video, which is part 2. In part 3, I will teach you about the AC analysis to prove the voltage gain of this power amplifier is fixed at 50, which is 34 decibel. Here is its complete circuit. And this slide shows the complete circuit of the LM380 power amplifier. So I want to guide you through about the detail of this circuit and identify the parts one by one. Let's start with the current mirror. Q11 and Q12 current mirror from the top, the PNP current mirror. And then there are two resistors, which is R1 divided by 2. The total of the two series resistances are 1. And then there is a bypass capacitor, CB. So here's the input differential pair, Q3 and Q4. There is a resistance, R3, connected to PNP transistor. And then there are input emitter follower. So the inverting terminal of the power amplifier on the left and the non-inverting terminal of the power amplifier on the right. So Q5 and Q6 is a current mirror of the input differential amplifier. So here comes the second stage, the common emitter amplifier. So it's the MPN Q7, which serves a common emitter amplifier, again, the provide gain. And there's a feedback capacitance. This kind of technique is called Miller compensation. And the compensation capacitor is C. And there's an internal feedback capacitance, R2, connected between the output and the input differential stage. So this is very important. You will see the effect in the AC analysis. So again, the feedback capacitance is connected between the output and the input differential stage. What's this? The series of the two dial provides the bias for what kind of output stage? For the class AB output stage. So the class AB output stage is composed by two parts. The upper part is Q8, which is the single NPN transistor. So what's this? The lower part of the class AB output stage is called the Q9 is the PNP. The Q10 is the NPN. So this kind of composition is called compound PNP. So this is the complete circuit of the IC power amplifier. So again, the red part is bias of the power amplifier. The green part is the input stage. Differential pair, Q3, Q4, the emitter follower, Q1, Q2. And the last one is the Q5, Q6 serve as a current mirror. So differential pair, emitter follower, and then the current mirror. So the blue part is the gain stage. So bias, input stage, and gain stage. So common emitter amplifier and Miller capacitance. So this is the output stage, which composed of is the class AB output stage composed of a single NPN and a compound PNP. Again, the two diodes provide the bias for the class AB output stage. Single NPN on the top and compound PNP on the bottom. So the learning objective of this lecture is that you can identify each part of the circuit, including the current mirror on the top, the PNP current mirror, and the Q3, Q4, the input differential pair, the Q1, Q2, the emitter follower, and the Q5, Q6 is the current mirror. And gain stage, you have common emitter and Miller capacitance. And R2 is what? It's the feedback capacitance connected between output and the input stage. The two diode is the bias for the class AB output stage. And the single NPN on top and the compound PNP. So this is the end of the lecture. Thanks for watching.